If the voltage in a parallel connection stays constant, then why did the voltage drop to 2 volt here? For those who are new, this series uses www.falstad.com for circuit simulations. Hey everyone, we're looking at the potentiometer divider circuit from the Falstad simulation series. A potentiometer divider circuit is simply a variable voltage divider. The potentiometer has 3 terminals, 2 ends of a resistive track, and 1 movable wiper. As the wiper moves, it changes the ratio between the 2 resistances, which in turn changes the output voltage. This makes it useful for adjusting signal levels, tuning circuits, and controlling inputs like volume or brightness. If you've watched the previous voltage divider and potentiometer videos, you already know how the circuit works. If you haven't, keep watching these videos. We imagine the potentiometer as 2 resistors connected in series. As you turn the wiper on it, the resistance of these resistors changes, but the total stays the same. This makes using a potentiometer as a voltage divider much easier. So what do series-connected resistors do? As you know, in a series connection, the current stays constant. If the current and resistance stay constant, then the changing value is the voltage. This is how voltage division becomes so simple. To understand the circuit more clearly, let's calculate the 2.5 volt voltage. For this, we need the total resistance of the circuit. The voltage is 5 volt and the resistance is 1 kilo ohm. So the current in the circuit will be 5 milliampere. That means we have all the information needed to calculate the voltage at this point. Voltage is 2.5 volt. Up to here, everything should be clear and easy to understand. Now it's time for the main question. If, as we always say, the voltage in a parallel connection stays constant, then why did the voltage we calculated here drop to 2 volt? It's true that in a parallel connection the voltage stays constant, but it also changes. How? The main reason is Ohm's law. Because the equivalent resistance of parallel resistors decreases according to this law. So the resistance of this circuit becomes approximately 333.3 ohm. In that case, the total resistance of the circuit will be approximately 833.3 ohm. When this happens, the total resistance of the entire circuit automatically changes. Current is approximately 6 milliampere. In this case, the voltages in the circuit are divided like this. So first part current is 3 volt and second parallel part is approximately 2 volt. So, to understand how a 1 kilo ohm resistor affects the circuit, you actually need this kind of calculation. That's all. If you found the video helpful, check out our other videos too. Subscribe for more electronics tutorials and click the bell. Bye.